Um, Hello, my name is Yosua Octavianus, and right now I'm going to explain you my answer of number 4, 5, and 6. So number 4, we are asked to create a mathematical model for this case and create a spreadsheet model for the point A. So I just laying out the data here, and this is how I use the mathematical model for this case. So this is like day one, week one, and month one. So this is how many shoes that the company can produce in day one, week one, and month one. And this is the male, female, and total shoes. So basically, what am I doing here is um just like um this is a 30% of the employee, so this is C3 divided by 2 because there's two types of shoes, so I divided by 2, and then times F3 divided by G3. So F3 is a workday, how many hours per day, and this is the G3, the time to create a pair of man shoes. So this is the man, sorry, type. So this is the man shoes. I divided like how many shoes are going to be produced in 8 hours. So in one day is 8 hours, and then this is how much they produce, and this is the female one, and then this is the total shoes. So in week one, I just times it to 5, because one week is 5 days, 5 days work. So I just times it like this: F3 times E3 E3 times this, 40, and then divided by a time to create, and then this is month one. Yeah, it goes like this because um is a 1 week. 1 month is 4 weeks, so just times it times 4. So this is how the profit goes. So I just took the actual produced and the finishing, and then times it with the profit of the shoes. So yeah, there's basically it. So week one just times it um with this and this, and then this with this. Okay, so moving on to number, I mean a 4B, I think. Yeah, 4B. 4B. I just laying out some. Oh, this is the spreadsheet for model point A. This is one, and this is number 5. This is number 5. So I created a graphical interpretation of the case. So like this, the employee 50, and the production is 40. Like the employee that working for in the production, and then the finishing employee is 10 people. Working time is just 5 days a week and 8 hours a day. Total hours is 5 times 8, 40 hours, 40 hours a week. And man shoes, and this female shoes. These are basically based on the data that we are given. So this is the estimated profit as the data that's given. So this is male and female. I didn't use XY because I think using M and MFV, MNF is more recognizable. So this is the equation one. This is 2.5 male and plus 1.5 female. So it's equal 1600. and this equation 2. So basically just doing the equation so that I can get a result of the actual the actual optimal solution for the using the Excel solver. So this is number 6. Moving on, number 6, Shane is a project manager. So this is Shane, project manager for software development. We are asked to create a job sequencing for this case and find the optimal sequencing for this case. So this is I think this is for this is for a sequencing model. The first model is a FCFS, SPT, due date, and Slack. So I'm laying out this model one by one and finding out the average completion, the lowest average completion and average tardiness. Oh, sorry, this is a bit typo. Tardiness. So basically, what am I doing here? It's just I'm laying out this one model master user, and then the complete still the same as in the data, but so FCFS is the same as the data, but I mean same as the data, the sequence of the data that are given, and then uh just adds up like this, like day 4 is C16, day 15, like where is it, this one and times this equal this one times this equals this. So we adds up, and then the tardiness just minus complete and minus due date. So I use max 0 because I don't wanna have a minus nominal in the table, because it will ruin the average and the sum up. So just cap to 0. So this is the FECFS, and this is the SPT. The SPT is a short processing time, so I use the lowest processing time from number 3. There it's 1, and then sort I sort the data so that the lowest processing time will be up top, and then the same thing as goes on, plus this equal this, and the same with the tardiness, and then we get a result of this. And then next one is due date. Due date, we use the due date as a sequence, so we use this. So basically on the data is lowest is 9, so I put 9 here, and then it goes on as goes on. I put normally because I think I already done some of this. I already put up the table, and then I had to do manually. So yeah, that's a bit of a mess. And this is the same thing. Plus this equal this, plus this equal this. So the average completion is 20.5. Average tardiness is 3.4. So the last sequence model is a Slack. So Slack formula is due date minus today's date. I put up today's date as a 0. So it I hope that explain some. So this is how I do the Slack sequence model. First you this one, this uh this is the due date, F3. So I think I use in here minus 0. 0 is today's date, and then minus with D3 due date, the due date. I mean oh, I mean sorry, the D3 is right here. The times in days. So I just minus the due date, I just minus the due date and remaining processing time, so I get this. I mean this one. So the sequence. I mean, I'm searching for the lowest um the lowest oh wait, oh I forgot. um oh yeah, so I uh I switch up the sequence. So number one is not master user anymore. It's a master menu because it's number one. And number two is a test student, as you can see it's number two here. And then number supervisor is number three. So I switch up the sequence, um, so that I can complete the um, the table of the sequence model. And then this what I think this is probably the longest. This is not efficient. So I came up with the conclusion. So due date is the most efficient. Yeah, the due date sequencing model turned out to be the most optimal model because it has lowest average completion days, which is 20.5 days, and lowest average tardiness days. Thank you.